In example 3, let's deal with something that's a little bit more ugly of a function, a rational function specifically. So example 3 gives us f of x is equal to 2 over x plus 3. So what they want me to do is to find the domain and range of the original function, then use the algebraic method to find the inverse function, and then state its domain and range. And there's a little chart on the handout. I'm going to copy the little chart over here. We have f of x, and then we'll have the inverse. And then we need its domain, and we need the range. Okay, so let's see what we can do. The domain's the easy part. We know that from the denominator in this original function, x cannot be a -3. So we're going to go from -infinity to -3 and -3 to infinity, squeezing it in. What about the range? Well, the range is going to come from the horizontal asymptote. Luckily for us, we know how to find the horizontal asymptote. So comparing the degrees, it's bottom heavy. That means it's the line y equal to 0. So we know we have to avoid 0. So -infinity to 0 and 0 to infinity. Okay, now if we've done everything correctly, what's going to happen is these two are going to switch places for the inverse function. Okay, but we'll hold on to that for a minute. So what we need to do next is use the algebraic function and find algebraic method to find the inverse function. So we're going to write some steps. So the very first step, I want you to replace f of x with y, and because that's what y is equal to, and we work better solving in terms of y. So we're just going to take out the f of x and write it as a y. Okay, your next step is we're now going to switch or interchange x and y. So swap them. So that means every place I have an x, I'm going to write a y. Every place I have a y, I'm going to write an x. All right? So that would be x is equal to 2 over y plus 2. And we're going to solve for y. Step 3, solve for y. We can do that. It's got a fraction. We can clear the fraction. So that's the first thing to do is multiply by the common denominator. I'm going to put it in a set of parentheses. That's going to remind me that on this side, I'm going to have to distribute. So I have y plus 3 in parentheses, the quantity times x is equal to 2. So let's distribute. It would be xy plus 3x is equal to 2. I'm solving for y. So that means let's move the 3x. And then finally divide out the x. So y is equal to 2 minus 3x all over x. And then finally, step 4 is just to make it look like the inverse function. So now we're going to replace y with f inverse of x. So just to write it as the inverse function. So for us, our inverse function is going to take 2 minus 3 times x and divided by x. So notice how much uglier that looks for the rational function as an inverse. So again, up here, you would take and add the 3 and then divide it into 2. So down here, notice we're doing some much different looking stuff. This is saying we're going to take and multiply by 3. We're going to subtract it from 2, but we're also going to divide it by x. So a lot more complicated. That's why we didn't walk ourselves through it verbally. Let's see if we've come up with what we need, though. So in terms of its domain, it's just got an x in the denominator. That means I can't use 0 in the denominator. So its domain goes from -infinity to 0 and 0 to infinity. Exactly what we thought. Notice this thing is switching. Right? What about its range? Well, the degrees are equal. So it's the ratio of the coefficients. That's -3 over 1. So its horizontal asymptote would be at y equal -3. So -infinity to -3 and -3 to infinity. And sure enough, they switched places just like we said they were going to. So, okay, hopefully you wrote these steps down. If not, stop the video and write those steps down. In cases where a given function is not one-to-one, we can sometimes restrict the domain to create a function that is one-to-one and then find the inverse. So our next example shows us how to restrict the domain in order to find the inverse function. This is example 3. Back to our friend, the parabola. I'm sorry, this is example 4. Keep my numbering right. So this time the function is x plus 1 upon b squared. So the directions say restrict the domain to create a one-to-one function, then find the inverse function, state the domain and range of both. Well, what we're going to do first of all is let's go ahead and graph this just to get a handle on it. So we know that's a parabola. We also know that the vertex has been shifted to the left one. So I'm over here at -1, 0. If I plug in 0, I'm going to get 1 squared, which is 1. I just want a little bit better picture. So it looks something like this. So not 1-to-1. So what we're going to do is make it 1-to-1. We want it to pass the horizontal line test. So to make it pass the horizontal line test, I'm going to get rid of the left side. You could get rid of the right side. It does not matter here, but this is generally what we tend to do. So we're going to restrict the domain to be 0 to infinity. In other words, we're going to let x be greater than or equal to 0. So I now have 2 points on my function. Yay! Okay, so right now we could actually graph the inverse function because we saw earlier in an example that all we do is switch the x and y points, the values. But hang on, we'll graph this in a minute. Let's go find the inverse first. So now let's find f. Now find. So let's walk through our steps. The first thing we do is take out the f of x and write a y. Then we switch the x and the y. And now we're going to solve for y. Well, because x is equal to the quantity squared and we're trying to solve for y, we're going to have to square root both sides, which we expect because it should be the inverse of squaring is square rooting. So we do expect to see this. So the square root of x is equal to y plus 1, and then we'll move to 1. Square root of x minus 1 is equal to y, and finally write it as an inverse function. So the inverse function, just like we kind of think it should be, is the square root of x minus 1. Now the minus 1 is outside of the radical. That's important. Okay, it doesn't ask me to graph it, but I'm going to go ahead and graph it so we can get a handle on it and see it, and also help us find the domain and range. So that is the square root function. That's that half a parabola opening to the right, but it's been shifted down 1. So sure enough, if I shift it down 1, I get the point 0, -1. And if I reflect this guy, changing the x's and the y's, I'll get the point 1, 0, and it's going to go like this. So here's the inverse, here's the original. So the cool thing that we'll point out later in the handout, but I think it belongs right here, is that if we take a look at these two, and I draw in the line y equal to x, so that would be right through the origin with the slope of up 1 over 1, up 1 over 1, you're going to notice that this thing reflects across that or folds across it. It's symmetrical with respect to the origin, which we talked about a long time ago, but it's really saying that it folds across the line y equal to x. Really cool. Okay, now we're going to come in and find the domain and range of both of them. And the picture is going to help us do that. So we have f inverse, we have the domain of this one, and the range of. Okay, so the domain of the original function, well, we restricted it, remember? So we know it goes from 0 to infinity. Now, according to my picture, this is f. Its range is starting at 0 and going up. Sorry, I did that wrong. Wow. And I just now caught it. You're probably screaming at me the whole time. It just didn't hit me until now. We restrict, that would work. So recognize that that would have worked, but I actually am restricting -1 for my x's. Sorry about that. I didn't catch it until here. Because we're not centered at the origin, we're centered over there. The vertex is at -1. So I really want to restrict to the vertex going to the right or to the left, but we get to the right. So that should be -1. And now that matches this picture. And now that's going to give me the correct range at 0 to infinity. I could have done 0 and just used that. That would have also worked, but we didn't. Okay, now that's going to work for the inverse function. So we're just going to interchange these. Sure enough, that matches our picture. There it is. So the domain starts at 0 and goes to the right. The range starts at -1 and heads up. There it is. And there's the inverse function for two different types of functions.